Good afternoon, good morning, whatever time of day it is that you're watching this. You're watching the 5.2 notes for geometry. Last lesson was just introducing parallelograms and some of the qualities that are true about a parallelogram. And today we're just going to take a little bit of a deeper dive on that. So, a parallelogram, as we know from the previous lesson, is a quadrilateral, meaning it has four sides, that has two pairs of parallel sides. We use that little symbol right there to name a parallelogram. For example, we could talk about parallelogram ABCD, which is right there at the center of the picture. So what are some things that we know? We know about parallelograms that opposite sides are congruent and parallel. So this side is congruent to this side, and this side is congruent to this side. And not only that, you can already see the markings there that this side is parallel to this side, and this side is parallel to that side. Hence the name parallelogram. Also, our opposite angles are congruent. And then last but not least, and the drawing's getting a little overwhelming, our diagonals bisect one another. So this half is congruent to that half, and this half is congruent to that half. So, with that being said, let's look at these questions one by one and see if we can't answer them real quick. If AB is 12, well then DE must be 12. Boom. Right? Because opposite sides are congruent. Some of these are going to be real quick, right? Real quick. If AD is 22, well then BE must be 22 because opposite sides are congruent. If AE is 26, well then CE is half of that, so 13. Why is that true? Because diagonals bisect. Let me go ahead and just make note of what fact I'm using. Opposite sides are congruent. Opposite sides are congruent. Diagonals bisect. If B to C is 14, well then B to D, which is the whole thing, has to be 28 then, right? 14 and 14 make 28. Again, I'm using the fact that diagonals bisect. Let me clean this up a little bit because we're going to get too many numbers happening. If ABE, A to B to E, if that angle is 106, which clearly isn't very accurate, but we're going to pretend it is, then A to D to E must also be 106. If BED, I'm going to clean this up because too many lines it just gets confusing. If B to E to D is 125, then ADE, well, it's not we didn't list, I guess I ignored this fact, didn't I? I forgot to say this one out loud, didn't I? I went 1, 2, 3 and kind of forgot to say this out loud. Consecutive angles are supplementary. The best reasoning for this, right, to maybe help you remember, is when you look at a parallelogram here, this side is parallel to this side, right? And this left side is essentially a transversal, right? If you think back to our angles and stuff, these are consecutive interior. We already know that consecutive interior angles are supplementary and that alternate interior angles are congruent, for example. Those are some of the buzzwords from that particular unit. a month or two ago, whatever that was at this point. So we're bringing that back up again. But again, consecutive just means in a row. So where this angle is opposite of this angle, the ones that are in a row, well, A is followed immediately by B. So A and B are consecutive. B is immediately followed by C, so B and C are consecutive. So when you look at this, BED is immediately followed by ADE. They are consecutive, so they need to add up to 180. 180 minus 125 is 55 degrees. So we're using the fact that consecutive angles, and that's how I do angles, right, with the angle symbol and then an apostrophe S, that the consecutive angles are supplementary. And I forgot to say here that opposite angles are congruent. And then last but not least here, D to A to E right there is 76 degrees. How large is B to E to A? Well, again, not to sound like a broken record, but again, these are parallel lines. And again, it's just a matter of recalling our angle relationships. 76 here, well, they're on alternate sides of the transversal and in between the parallel lines. The best way I like to think about that is we have alternate interior angles. Boom. Just like that. Quick facts. Most of those, I think, are pretty easy. Again, we're just going to stick with it, right? Here's another drawing and just boom, boom, boom. Solve for all the angles, okay? So if we know that this is... So here's a pro tip, right? When looking at problems like this, don't start with the first one just because it's first. Look at your drawing and just figure out the ones that you know right away. Well, when I look at this, again, with the whole alternate interior situation, I'm like, well, that one right there must be 35 degrees, right? And if this is 79 right there, well, then this one up here must be 79 degrees. If you kind of tilt this, if you look at it at an angle, right, that is another set of, okay, we got our parallel sides, and these are on alternate sides of the transversal and in between the lines. So alternate interior. So that's 79. Well, now that I know that that's 79, what I'm starting to see is a triangle right here, right? That's a triangle. So obviously, I guess it's a triangle, right? But why am I pointing that out? Well, how many degrees are in a triangle? 180. Right? I'm not looking at this as like, oh man, I got to bring up all these parallelogram facts. A parallelogram is simply triangles put together. It's simply a couple of parallel lines stacked on top of each other, right? It's stuff that we already know, right? It's just that it's being mushed together, okay? So here's the triangle. Well, 180 minus 79 minus 46. How many degrees are left? 180 minus 79 minus 46 leaves me with 55. So this is 55 degrees. Well, I keep seeing more and more facts that we already know. This is vertical angles. So then, boom, that's 55 degrees. And I don't know if you love it or hate it. Here's another old fact. This is a linear pair, right? This is a straight line right here. And we have a pair of angles, 55 and this guy. Well, how big is that guy? 180 minus 55 is 125. So that's 125. And then boom, another vertical angle. And then once again, I have triangles. I know that this is 35, and I know that that other angle is 125. So when I subtract the 35 and 125, I end up with 20. And if that's 20, well, then this is 20 because it has the same two angles in it, right? It's like the exact same triangle. You realize that, right? It's just been rotated, of course. So if this is 20, that's 20, 35, 35. And this is the same triangle right here, too, right? 75, 70, or 79, 79, 55, 55. So therefore, that last angle must be 46. I hope I didn't go too quick. If I did, rewatch it, right? I was talking about that for like 2 minutes. Spend another 2 minutes and soak it back in again, okay? So let me actually label these now. BDA. B to D to A. Well, that's the 135. Or sorry, the 35, not 135. And then B to F to A. Well, that's the 55. And then E to F to B. Well, that's the 125. B to E to F is the 20. And then D to E to B. Well, D to E to B is actually a combination of the 79 and 20. So that's 99. Like I said, go back and rewatch that if I hit anything too quick. All right. Last but not least, again, we're just using these facts to solve. Right? Oh, this is equal. Oh, this is equal. Oh, this is parallel, right? That's all we're doing. So when I look at this drawing, I'm like, well, if I'm trying to solve for x and y, I know that opposite sides are congruent in a parallelogram. Congruent meaning they're equal. So boom, set it up. Easy. Easy. Right? I mean, come on. It doesn't get any easier. Come on. Easy. A fact that you might not remember as quickly. I sometimes don't remember it as quickly, but nonetheless is still true, is that the diagonals bisect. Bisect meaning bi meaning two, sect meaning to like intersect, so split apart. So they've been split into two equal pieces. So this piece is equal to this piece, and this piece is equal to this piece. So 31 is equal to 7k minus 4, and then the 4j plus 9 is equal to the 6j minus 5. Add the 4. Divide the 7, k equals 5. And then when I solve this one, subtract the 4j, add that 5, divide the 2, j equals 7. And then one more time, last but not least, we've got some angles and some sides. I see students sometimes start to mix things up, right? You're never going to set an angle equal to a side or something weird like that, right? Sides are sides, angles are angles, right? Their measurements are different. So I'm looking at this and going, okay, this side is congruent to this side. So set those equal. And why is that? Opposite sides are congruent. So G is 3. And then here, what do we have here? You might be tempted. You're like, well, every single one of those problems, you set it equal. Not this time, I'm not. Why? Why? These angles are consecutive. They are not opposite of one another, right? They are not on opposite ends of the shape here. They're consecutive, meaning one right after the other. And again, if you're struggling with that word consecutive, and what I mean by one right after the other, right? If you were circling around this object, the angle comes after 72. F plus 30, right? It comes right after it. That's what consecutive means, one right after the other. And what is true about consecutive angles? They are supplementary, meaning that when you add the two angles, they will equal 180. Subtract that 102, you end up with 78. Boom. And that's it. Let's make this the shortest video of all time. Thank you for watching. 16 minutes. Wow, we did it. You're smart. We're incredible. Thank you for watching. Easy. All right, see ya.